As an introduction to the efficient cause paired orderings analysis option in the observation-oriented modeling software, let's take a look at a recent study on stress. In 2013, Shota and colleagues asked participants to think of an event each day and rate the stressfulness of that event using a 0 to 10 scale. Now, the participants were also asked to rate various feelings and fears with regard to those same events. So you see here feeling anxious, feeling incompetent, feeling time is wasted, and then fear of failure, fear of letting others down, etc. And they made these ratings on approximately 50 consecutive days. And the primary goal of the research is to identify individual triggers for stress. For one individual, it might be feeling defeated. For another individual, feeling confused may be the trigger for stress. Now, Shota and his colleagues analyzed the data using hierarchical linear modeling. You can see a generic model here on the screen with its requisite assumptions, including the assumption of continuous quantitative measurement. And here we see the results for one individual, participant number 9. Along the x-axis are the different feelings and fears, and along the y-axis are the slope parameters from the HLM analysis. And as you can see with the red line here, feeling excluded has the largest slope, indicating that it's the best predictor of stress for this participant, participant number 9. Feeling inferior would be the second best predictor for this individual participant. The blue line represents the average across all of the participants. And what is clear here is that participant number 9 does not match the average, and that again was the point of the research, to try to identify individual triggers of stress. Now, in observation-oriented modeling, we're going to analyze these same data using the efficient cause analysis. And here we see an example of how this analysis will be conducted. Notice along the bottom we have the stress daily ratings, and we have 53 days of ratings for this individual. And then across the top we have the feeling ratings, again for the 53 days. Now, the stress is the effect, and that is the blue line. And the cause in this case is fear of being viewed by others as incompetent, and that's the red line. Now, you can tell that the lines match each other in terms of their pattern across the 53 days. Now, more specifically, notice that from day 1 to day 2, the stress and fear ratings go down, and then from day 2 to day 3 they increase, and then from day 3 to day 4 they decrease again, and so forth. So we can tally the number of times that the changes in the stress and fear ratings agree across the 53 days, and that will give us a percent correct classification index, the PCC. Now, for this particular example, it's 96%. Now, these are contrived data, but they show us what to expect as we're going to switch over now to the observation-oriented modeling software to analyze the actual data from Shota et al.'s paper. So here we see the data for person number 9 in the OOM software. We also have data open for person number 13, just to show you that each individual is his or her own data set. Notice that the number of cases is 24, and those correspond to the different feelings and fears. And then we have 160 orderings, and those correspond to the different fear ratings and the stress ratings. As we scroll over, we can see the fear ratings for this individual. We have 53 days of fear ratings, and then 53 corresponding days of the stress ratings. We also have these M orderings here, but those are of no concern for this video. So we'll select the Analyses, Efficient Cause, and Paired Orderings option from the main menu. We're going to move the various fear ratings, or 53 days of those, over to the Efficient Cause Orderings box. And now we're going to match those up with the effects. In this case, the 53 days of stress ratings. And now we're ready to begin examining the observations or the data. And we'll do so by selecting the Examine Patterns button. I'm going to stretch this out just a little bit and magnify this so we can see it more clearly. And we'll start with anxiety. So here we have the anxiety ratings represented by the red line, the cause. And then the stress ratings are the effect, the blue line. And your eye tells you that these two lines match up pretty nicely. So this seems to be a good candidate for a trigger of stress for this particular person. but you'll notice that the PCC index is only 30.77%, which seems fairly low compared to the eye test here for these two lines. Now the reason for that is because of the options that we've chosen. So you can see here in the main options window, we've selected the Analyze Deep Structures option. Now with that option selected, the PCC is computed by matching the ratings on each day. So for day number 1, if the feeling anxious and stress ratings match, then that's a correct classification. On day 2, if they match, it's correct. On day 3, and so forth. So that would give you 52 potential matches here, since we have some missing data for day 43 on the feeling anxious ratings. But that's not what we want to do. We want to look at the ordinal changes in these ratings in the original unit of observation, the 0 to 10 scale. So we want to look again for changes from day 1 to day 2, day 2 to day 3, and so forth. So we need to go and select the numbers ordinal option. We'll do that in just a second. Now also notice that we've selected the ordinal classifications full option. We're going to switch that to adjacent as well, because what we want to do is again look from day 1 to day 2, day 2 to day 3, day 3 to day 4. And that would mean then an adjacent only classification approach. Now with the full option chosen, as we can see here, what's happening is that the PCC is computed based on all possible pairwise comparisons across the 53 days. So changes from day 1 to day 2, from day 1 to day 3, from day 1 to day 4, and so forth, then from day 2 to day 3, day 2 to day 4. So all possible changes across all 53 days of data. That probably doesn't make a lot of sense, where we're just looking at from day to day, are there relative increases and decreases in the two ratings. So let's close this window and now select the numbers ordinal and adjacent only options. Then we'll go back to the examine patterns, and I'll magnify it again where we already have anxiety there. And now we see the PCC is much better at 70%, which matches the eyeball test here. We're looking for the relative changes, and they seem to match across the 53 days fairly well. We can scroll through the other feelings. Feeling incompetent doesn't pass the eye test. Those two lines don't change in a corresponding fashion, and the PCC is only 42%. Feeling exhausted, again, the lines don't match up very well. PCC is again 42%. Feeling behind, match a little better. The PCC is still only 52% though, not very good. Feeling defeated, and so forth. So we could scroll through all of these different feelings and fears. But let's go ahead and close this window and select the randomization test and the individual results, and we will run the analysis by selecting OK. It iterates through and takes us to the text output window, and at the very bottom of the output is what we're looking for in this particular study, the individual summary results. So notice here is the 70% for the feeling anxious. We now have a C value, which is less than 0.1, so that's impressive. Feeling incompetent, the PCC is 42%. We saw that a moment ago. And you can scan down all of these PCCs and see that, indeed, anxiety is the best potential candidate for stress, as a trigger for stress, for this participant. You notice we get a 60.42% for feeling overwhelmed, 64.58%, that's the next highest PCC, for feeling rushed, and then we get another 60% for feeling expectations were violated. But again, feeling anxious seems to be the best candidate for a trigger of stress for this individual. Now we can scroll up and see the overall results, which really aren't of any interest here. So notice if we look at across all feelings and fears, there are 1,170 possible pairwise comparisons there in the relative changes, and of those about 49% were correctly classified, which is not impressive at all. But again, it's not a result we care about for this analysis, even though the C value is also quite low. Classifiable complete cases, there was only one feeling for which this participant provided ratings for all 53 days, and in that case the PCC was not 100%, which is not surprising given the complexity of the data. But again, these results are of no interest to us for this particular study. With feeling anxious thus identified as the best candidate as being a trigger for stress for participant number 9, We could then return to the data, look at participant number 13, run the same analysis, and then attempt to identify the triggers of stress for that individual.